Hi, my name is Brandon Graisley. I'm a high school math teacher. I'm going to show you how the slopes of parallel lines are related and how the slopes of perpendicular lines are related. So here I have two different lines. We're just going to do this with an example. I'm going to identify a couple of points on the first line down here. There are 2 points that are on the line, and I can see that the run here is 1 and the rise is 2. 1 there, 2 there. Together this gives us a slope. We'll call this line's slope M1. Gives us a slope of 2 over 1, or 2. We have another line right next to it here. It is a parallel line. I can identify 2 spots on this as well. And once again, we have a run of 1 and a rise of 2. And so we get the same slope. So I'm going to just write up here M2 equals 2 over 1 as well. So you notice that I use a little subscript on each of the slopes so that I tell which one is which just by looking at the slope number. Okay, so this is true for all parallel lines, that the two slopes are always the same. So I'm just going to write that down here. If two lines are parallel, their slopes are equal. And so you might write something like M1 equals M2. So that's fine. Let's go take a look at the more complicated situation when we have perpendicular lines. So you'll have to just trust me that these are perpendicular, and so we often put this little square symbol in the corner to show that they're perpendicular. And once again, we'll calculate the slope of each of these lines. Let's call this line here number 1, and I'll identify a couple of points. There's a point right there on the line. If I follow along, I actually find another nice point right here. Let's calculate the rise and the run. That's 2 and that's 3. You can use the coordinates if you want to, but it's pretty easy to count on the grid here. So we'll say this one has a slope M1 of 2 over 3. That's it. That's the fraction. Let's take a look at this other line. We'll call it line number 2. And there's a point I can identify. And maybe I'll follow up this way. Looks like there's another good point right there. Following the rise and the run, well, the run here is 2. The rise, though, is negative 3 going downhill as we go to the right. It does have a negative slope. So M2 is negative 3 over 2. Now you see this relationship here. These fractions are the same except one is the reciprocal of the other, and also one is negative and one is positive. And this is the effect that we are always going to see. So if two lines are perpendicular, sorry, a little further up. Their slopes are, and we say, negative reciprocals. So in this case we had, well, let me write this out in a little more detail here. So we would say that M1 is equal to, now there's a couple of ways to write this. This is one way here. Negative 1 over the other one. So that's one way that we can write it. The other effect that you might see is that if you were to multiply those two slopes together, you always get negative 1. I'm going to show you that in a little bit more detail just to prove that that's the case here. So let's take two reciprocals, let's say 5/12, and we'll multiply it by 12/5, and let's make one of them negative. I'm going to make the first one negative. This is going to be a negative result because both are positive, or sorry, one is positive and one is negative, so we get a negative result. And then the fraction that we get is 5 times 12 on the top, 60, 12 times 5 on the bottom, also 60, which is equal to negative 1. This will be true with any pair of reciprocals. If you multiply them together, you get 1, and if they have different sign, you'll get negative 1. So that's our rule. We use that to determine slopes of perpendicular lines. So for example, find the slope that is perpendicular to the line. I'll give you an equation. Let's make this let's say 4/3 x minus 7. So to solve this, we first identify the original slope is 4/3. Let's call that m1. m2, since it has to be perpendicular, will be -3/4. And we'll sometimes use the symbol m with a little, looks like an upside down T, to show the perpendicular nature of it. So that is -3/4. So those are two different ways that we can write it. Okay, I hope that's helpful, and let me know in the comments if you have any questions. Thanks.